Hello everyone, in this video I will be talking about rigid bodies in Unity. So I have a scene setup over here which have a environment, the main camera, directional light, player 1 and the player 2, and player 1 and player 2 both have a rigid body component over here, and the player script you can see over here. The player script is nothing but it takes the rigid body component of the player and adds the force in the direction of the vector which you will provide in the inspector. So let's go to the inspector. It is providing the vector of -1000 Newton to this body and 1000 Newton to the green body, the green game object. See. So what will happen if we run the game? Let's test it. So here we can see both are moving towards each other, but one is moving at the lowest speed and other, which is a violet game object, is moving at the highest speed. This is all happening because the mass of the violet is 1 and the mass of the green is 4. So greater the mass, the greater the tendency to rest at the position. And using the Newton's second law, if we see force is equal to mass into acceleration, so both have the force of 1000 and the mass of the violet one is 1 and the acceleration is a. So the acceleration will be 1000 units. But on the other hand, a force of the green game object is 1000 and the mass is 4 and acceleration is a. So the acceleration will be 250 units. That's why it is moving slow. So whenever we alter the mass of the game object, the rigid body, we have to keep in mind about the inertia of that game object. The second is drag. Here in the scene, player 1 and player 2 now both has the mass of 1. You can see, but the drag of player 1 is 2 and the player 2 is 1. Both are applied with force of 500 Newton in the same direction. So let's play the game and let's see what will happen. So here we can see this player 1, which has a drag of 2, is moving very less speed, but player 2 is moving with a very high speed and it has a high terminal velocity. Here speed is 4 and here speed is 1 or 2, something like that. So why it is happening? So drag is a property which opposes the force of the motion, and you can see with the example, when you drop something in the air it falls with a high velocity, but if there is a parachute it falls with a low velocity because it has a more drag. The third property is angular drag. Here we can see, and I have just changed the player script little bit. I have just add torque instead of add force and given it a torque of 1000 in the y axis. So let's play the game. So it is moving, it is rotating, right? If we increase the angular drag, you can see the rotation of the cube slows down, and if we reduce it to 0, it's again faster. The next property is use gravity. Very simple. Just turn it on and the object will fall. It's falling. The next property is kinematic. If we turn this on, then the game object will be fully controlled by the script, not by the Unity physics. So let's turn this on and play the game. For the green, I have turned this on and it will not be affected by the violet, and if we turn this off it will again move. But we can control it with the scripts. For interpolate, whenever your rigid body gets a jittery motion, it happens whenever your camera is following your rigid body. Whenever it happens, turn the interpolation to interpolate, and you can experiment with it. You can turn like extrapolate and interpolate they both smooths out the movement, but what happens in interpolate, it smooths out your movement between the last frame and the current frame, so it always lags behind. But in extrapolate, it smooths out the movement from the current frame and the upcoming frame. Next is collision detection. So it has a four: discrete, continuous dynamic, and continuous speculative. So the basic rule is to use the discrete collision detection whenever there is a rigid body which is very slow moving, and use the continuous detection whenever the rigid body is moving very fast, and the continuous dynamic for the more faster objects. But you have to know that discrete is better because it uses your less CPU, and it doesn't require much CPU usage instead of continuous dynamic. So this is it for today, guys, and the last thing which I want to say to you all, please subscribe to my channel, because more videos are coming on this topic, and the coding with rigid bodies and all the box colliders and how to detect collisions are coming in the next few days. Thank you.